Assalamu alaikum, students. Today, this is the part two of the revision process in which I was giving you session on the revision of mechanics for the end of term one finals. Last time we completed the portion of kinematics where I discussed in detail about the constant acceleration problems, whether the body is moving horizontally or the body is moving in a vertical motion where we considered the free fall situation. The value of acceleration was g. We call it acceleration due to gravity, and its value is 10. If the body is throwing upward, it will be slowing down. The value of g will be negative 10. And if the body is coming down, the value will be plus 10, right? And now this is the second part, and you can see the name of the chapter is Forces and Equilibrium. So, two things I'm going to discuss, and I think we have like 11 to 12 questions in this. Revision pack. I will try to discuss all of them in detail. So, first of all, guys, you need to understand what is a force. Force is a quantity in mechanics which has a magnitude and a direction. Suppose I have an arrow which represents the direction and it is 2 newtons force. And if I want to take the double of that, you can see that I have drawn a 4 newton force which is double than the force which is drawn before. So this is 2 newton force and now this is 4 newton force, right? So we will discuss some forces which are making an angle with the horizontal, for example, with the x-axis, and also we will say the forces which are making some angle with the y-axis. This is called resolving forces. This is the force and this is the x component of the force and this is the y component of the force, and the force is making an angle theta. So you understand that what is a force? Force is a quantity when you apply on any body. You see the force try to move the body, try to change the direction of the body, okay, try to stop the body. So these all effects are seen when the force is applied on any body. In forces and equilibrium, what type of situations we will see? If you have a P Newton force acting on a body at this point, and you have another force, Q Newtons, acting on a body at the same point, we can find the resultant of these two forces. Resultant means the body will actually move under the action of P Newton and Q Newtons, not exactly in the direction of P Newton, not exactly in the direction of Q Newton, somewhere in the middle, it will move. So, what we can make a parallelogram, supposedly an equal force here, which is the same as Q Newtons. And then I will draw this line, which is the diagonal of the parallelogram. This diagonal will represent resultant. If both forces are making an angle theta with each other, so as per the rule, this is corresponding theta and this is 180 minus theta. Then I will be focusing on this triangle. In this triangle, I can apply sine rule and cosine rule to get the value of r. So cosine rule tells me if you know this is q newtons and this is p newtons and you want to find the opposite, the cosine rule tells me r is equals to p squared plus q squared minus 2 times p times q times cosine of, what is the angle between them? 180 minus theta. At some later stage, I will tell you that cosine of 180 minus theta, why it is equals to minus cosine of theta. But for this case, you need to memorize this rule. So that's why in the place of cosine of 180 minus theta, I will write minus cosine of theta. And then you can multiply this with minus with this minus, and then finally you will get resultant is equals to p squared plus q squared plus 2pq cosine of theta. Wow. This formula is very helpful formula when examiner will give you two forces. Suppose he gives you in the exam 6 Newton force and he gives you 8 Newton force, and he gives you the angle between the two forces supposedly 30 degrees. Now, no need to do anything, no need to prove the thing which I have done just now. You guys will write the magnitude of the resultant. It is equals to 6 square plus 8 square plus. In cosine rule, you write here minus sign, but I am going to use plus sign. So 2p, which is 6, q is 8, time cosine. The theta, the angle between the two forces, is 30 degrees. So I'm going to write here 30 degrees. So I can easily find the magnitude of the resultant. But here he will not stop. The resultant is definitely making some angle with the 6 Newton force, I call it alpha, and resultant is also making some angle with the other force, I call it beta. So maybe in the exam, the examiner asks you, what is the direction of the resultant? So direction of the resultant, you have to tell that your resultant is making what angle with 6 Newton? Suppose it is alpha, and I want to find alpha. So this alpha is equals to, try to memorize it. I can prove it by cosine rule, but just keep it here as a formula in your mind. It is not provided in MF19, but I'm going to write it here. So alpha is always equal to, if you want to find the angle between the two forces, so alpha, which the resultant is making with 6 newtons, so you will write first of all sine on the top and the angle between the two forces, which was theta, and that is 30 degrees, divided by the resultant which we have found it. May I write it as 6 squared plus 8 squared plus 2 times 6 times 8 times cosine of 30 degrees. And here I'm not gonna write 6 because alpha resultant is making 6 newton alpha angle with the 6 newton. You have to write the opposite force, which is 8. So I'm going to write here 8, and then in the calculator I will write everything to get my angle alpha, which the resultant is making with 6 Newton force. Suppose if in the exam I want to find the beta, again same thing, shift sign or inverse sign. I'll write here same thing, sine 30 degrees, the angle between the two forces, and magnitude of the resultant, which is 6 square plus 8 square plus 2 times 6 times 8 times cosine of 30. And here I'm going to write the other force. Any resultant is making an angle beta with 8 Newton, but I will use the other force, and that force is 6 Newton. So I'm going to write here 6. Whatever the answer comes, that is my beta. Clear? When this will be used, again, I will summarize. Suppose in the exam, the examiner gives you F force, F1 force, and F2 force, right? And he gave you the angle between the two forces. Examiner says, can you find the magnitude of the resultant? So your resultant is R, and that is equal to what? Come on, F1 squared plus F2 squared. No need to write minus sign. Minus sign you use in cosine rule, but here you write plus 2 times F1 times F2 times cosine of the angle between the two forces. Now, supposedly your resultant is here, and this is making alpha with the F1. So can you tell me now how the alpha will be equals to? Alpha will be equals to shift sine, come on, sine of the angle between the two forces, which is theta, divided by the resultant's magnitude times with which force? Alpha is resultant and F1, so I'm going to use the other force, so F2. Same thing if resultant is making beta angle with the force F2, I can find beta angle. It is shift sine, come on, same thing here, we write sine theta over resultant. Now since I want to find beta, I need to write the other force, which is F1. So if the two forces are given to you, you need to use this formula. Let's go to another scenario. Suppose examiner has given you some forces. This is P force, this is Q force, this is R, this is S, this is T, and this is W force. Now, in order to do the the resolving of forces, you need to know what is your x-axis. So suppose this is my x-axis and this is my y-axis, and he must have told you that this q is making theta 1 with the x-axis, and this is making the r is making theta 2 with the x-axis, s is making theta 3 with the x-axis, rt is vertical, and theta 4 which the w is making. Now if you guys can focus on p, what are the components of p? So p is acting along x-axis, so I need not to resolve it. So its x component is, the x component of p is p. What is the x component of q? The x component of q is q cosine of theta 1. So P is the x component by itself because it is acting in the same direction. Q cosine theta 1, it is the x component of q. Now, can I write the x component of r? So this is x component of r. And how do I write it? R cosine of theta 2. Now, what is the x component of s? The x component of s is s cosine of theta 3. Can I write the components for w? So the w is, the x component is w cosine of theta 4. So all x components I have found. I'm going to write always x net. X net is if the body is being exposed to lots of forces, so horizontally where the body will move. So I will add all the right hand forces. So how many right hand forces I have? I have P, I have Q cosine of theta 1, and I have W cosine of theta 4. These are all my right hand forces. And I need to take the sum of all these right hand forces. Then you need to subtract the sum of all left hand forces. What are the left hand forces? I have the x components of the given forces. They are r cosine of theta 2. Since I'm writing them in a bracket, guys, so you please add all the forces which are acting on the left hand side. R cosine theta 2 and s cosine theta 3. There are only two forces which are acting in the opposite direction. So this is also done. Now I want to find my y net. Y net means all the forces which are acting upward minus the forces acting downward. Did I find all the y components? Answer is P has no y component because it is acting all alone along like x-axis. So there is no y component of P. However, if I want to look at Q, it has this component which is acting vertically upward, and that is equal to Q sine of theta 1. This component of R, vertical component, it should be R sine theta 2. This component S sine theta 3. This component W sine theta 4. And this component is all alone acting vertically towards the y-axis. So this is just T. It is not making any angle. So I'm going to take this T as it is. So what is my y net? What are the upward forces I have? I need to do everything in a bracket. Q sine theta 1 and plus r sine theta 2 minus all the sum of the downward forces s sine theta 3 plus t and plus w sine theta 4. After finding x net and y net, this is my x net and this is my y net, I will try to find the resultant's magnitude. I will I will find x net square plus y net. So that is basically the resultant's magnitude I will find. And as far as the direction is concerned, there is a formula which you need to memorize for the final exam. So alpha is equals to inverse tan y net over x net. So, guys, I'm just telling you that sometimes we need to use, if the two forces are given, then you can use these two formulas, which I actually derived from cosine rule and sine rule. But mostly we will use this thing a lot, in which I will find x net and y net and try to find my resultant's magnitude and also the direction of the resultant. Okay, so now after this, we will be starting on our revision pack. So this was the concept. If any other thing will be related to that, I will inshallah discuss with you guys while solving the questions. So let's start the first question. Here he gave us two forces, each of magnitude 8 Newton, acting in the directions of OA and OB. OA and OB. The angle between the forces is theta. So the guy has provided the angle between them. The resultant of the two forces, this point is to be noted here. The resultant of the two forces has component 9 newtons. Did he give us the full resultant? No. He gave us the component of the resultant in the direction of OA. As you know, there is an angle theta between them. Sensible thinking tells me that if we have the same forces, then the resultant should act right in the middle, yani leaving theta over 2 here, half angle here, and half angle here. So resultant is acting in this direction. But this resultant is not given by the examiner, yani this is not 9 newtons. Rather than giving you this 9 Newton, he told you that the component of this resultant in the direction of A, which is r cosine of, and this angle is theta over 2, r cosine theta over 2, is basically equals to 9 newtons. So let's try to solve this question by resolving our components. Okay? Now, this force is already along the x-axis, 8 newtons. Can I resolve this force along the x-axis? So the x component is how much? The x component will be 8 cosine of theta. So 8 newtons plus 8 cosine theta, these two components are basically equals to the resultant's x component, because the resultant is based on the x net, which is the sum of all the right hand forces minus sum of left hand forces. So resultant is based on the x net is 8 plus 8 cosine of theta, and y net, it is, this force has no y net, but I can draw the y net, yani the y component of this is 8 sine of theta. So 8 sine of theta is the y component of the 8 Newton force. Now, as everyone knows, resultant is always equals to x net squared plus y net squared. If you allow me, in the statement, it was written clearly that the resultant of the two forces has magnitude 9 Newton in the direction of OA. So it is not R. Basically, the guy gave you X net. So the X net is 9. Can I solve this equation to get the value of theta? So we can go to the calculator and write here 8 plus 8 cosine of x equals 9, shift solve, and it gives me 82.8. So this gives me theta equals to 82.8 degrees to the 1 decimal place. So my theta is found, that is 82.8 degrees. Now the magnitude of the resultant, can I substitute my values here? No need to write here 8 plus 8 cosine theta in the place of x net. X net is already 9. So 9 squared. And what is y net? 8 sine. In the place of theta, I will write 82 point, write it to the 2 decimal places, guys. 82.82 for the accuracy of our result. So 8 sine 82.82, and please put it under the square. Don't forget that, because y net square. I'm going to write square root 9 squared plus bracket open 8 sine 82.82 bracket close, again bracket close, and put a square, and this gives you 12 newtons. So 12 Newton force is the resultant of these two forces, and the angle was 82.8. Let's go to the question number 2. In question number 2, this force is already acting along x-axis. Can we resolve this force, 8 newtons? This is the x component. Can you tell me what is that? It should be 8 cosine of theta. Now tell me what is your x net. X net is how many forces towards the right hand side? The blue one, 10 newtons, minus the left hand force, which is 8 cosine of theta. 8 cosine of theta. This is your x net. And didn't you see the guy said write down in terms of theta the components of the resultant of the two forces parallel to the force 10 newtons. So that is x net. The guy, in other words, he's asking you what is x net. This is equals to 10 minus 8 cosine of theta, and perpendicular to the 10 Newton force. So perpendicular to the 10 Newton force, yani this one, which is y net, he's asking you. That is here only, which is 8 sine of theta. So y net 8 sine of theta. We found it. Now the resultant of these two forces is 8 newtons. What is the formula we studied? Where the formula is resultant is equals to x net square plus y net square. Resultant magnitude is 8, square root, x net is 10 minus 8 cosine of theta whole squared plus y net is 8 sine theta whole squared. Remove this square root and put a square here. And now it becomes 8 squared and 10 minus 8 cosine theta squared plus 8 sine theta whole squared. Now this becomes 64, and I write 10 minus 8 cosine of theta and 10 minus 8 cosine of theta plus 8 square and sine squared theta. 64, 10 times 10 is 100, minus 10 times 8 is 80, cosine of theta minus 8 times 10 is minus 80, cosine of theta, and minus 8 times minus 8 is plus 64. Cosine theta times cosine theta is cosine squared theta, and copy this thing, which is 8 square yani 64 sine squared theta. Just to enhance this concept that 64 cosine squared theta minus sine 64 cosine squared theta is equals to 64. So this thing you need to memorize because trigonometry we did not study. So 100 minus 80 cosine of theta. Come on, guys. I think it's better to add them up. So that is equals to minus 80 is minus 160 cosine of theta. And the 64 cosine square theta, 64 cosine square theta will give you, yani not, you just take 64 common, and cosine square theta plus sine square theta. And as per rule, this is always equals to 1. This is always equals to 1. So we got 64 is equals to 100 minus 160 cosine of theta. Guys, as I said, this thing is equal to 1. So 64 times 1 is 64. Now allow me to cancel 64 with the 64 and send minus 160 cosine theta to the left hand side. So 160 cosine of theta is equal to 100. Now send 160 to the other side. Cosine theta is equal to 100 over 160, 0, 0 cancelled. And I got cosine of theta is equals to 10 over 16, yani divided by 5 will give you, yani if divided by 2, sorry, divided by 2, it will give you 5 over 8. Is this the result is requiring from you? Check it out. Yeah, this is the same result which we want to get, but it has 3 marks. Although, guys, I have shown it so many steps, but if a student is very good at trigonometry, he won't have any problem, and good at algebra can easily help you to get this answer.